Okay, here we go. Picking up where we left off yesterday. We talked about sine, cosine, tangent. We talked about how sine was the ratio of opposite to hypotenuse, cosine was the ratio of adjacent to hypotenuse, tangent was the ratio of opposite to adjacent. And we used sine, cosine, and tangent to find missing sides of a triangle. And that's the reason we're going to pick up with this word problem here and actually use what we did yesterday to try to find, and notice something very important that'll mean more to you by the end of the day. We're still dealing, that's a right triangle. It says a certain part of a hiking trail slopes upward at about a 5-degree angle. That's not a very steep slope, right? After traveling a horizontal distance of 100 feet. So this man, he didn't travel 100 feet. He traveled a horizontal distance of 100 feet. He actually went further than 100 feet. Does that make sense? Why? That's a right triangle, Pythagorean theorem. Your hypotenuse is going to be a little bit bigger than your side there. So he traveled probably 105, 106 feet. We're fixing to find out. But he traveled a horizontal distance of 100 feet along this part of the trail. What would the change in the hiker's vertical position be? And we're going to do that first. The change in vertical position. He was here, and he's a little bit higher now, right? That's vertical position there. We want to figure out how much higher is he now than where he started. So ignore the y. We're not doing anything with y yet. We're dealing with the 100, we're dealing with the x, and we're dealing with the angle, which is 5. Reminder, you find the sine, cosine, and tangent of angles, not of sides. So we're going to set up an equation, and the way we always start these is by writing down SOHCAHTOA to find out what type of problem are we actually dealing with. Here's my angle. This is the side that is, do y'all remember from yesterday? Adjacent, opposite, or hypotenuse. The x would be opposite. It's completely, look where your angle's at. It's on the far other side. So that's the opposite side. So you're dealing with an opposite side, so that throws cosine out. And you're dealing with a 100, which is your hypotenuse or your adjacent? Adjacent. Since you're dealing with opposite and adjacent, this is a tangent problem. You write an equation. The tangent of my angle, which in this case is 5 degrees. And remember I told you there's a relationship between tangent and slope. And you see here that there's not going to be much change there because my angle is so small, my slope is so small. So I'm not going to have a big vertical change in this. So the tangent of my angle is equal to opposite over adjacent. Hunter, what was the opposite side?
X.
Over adjacent, which was? And we have to solve this equation. The tangent of 5 degrees is a number. Treat this whole thing just like a number. And we've got to solve this equation. Alex, how do I get x by itself? How do I get rid of this 100? How do I move it over here? Multiply. So in your calculator, you would type in 100 times the tangent of 5 degrees. Let me pull up my calculator here. Always make sure that I'm in radian mode, or excuse me, degree mode, that I'm not in radian mode. I am in degree mode. Quit. So I'm going to do 100 times the tangent of 5. Tangent of, like I said, it shouldn't be a very big, no, 8.7. So x is about 8.7 feet, I think is what it's measured in. So if you're going up a 5-degree incline, over the course of 100 feet, that's pretty long walk, you're only going to raise 8.7 feet. Now let's talk about, it also says, what distance has the hiker traveled along the path? So now we're looking for this distance up here. We're looking for y. Now, we didn't work any of these yesterday to where we had to find 2 different distances, to where we found one and then we found the others. Let me explain the options here. You now know that x is 8.7 and that this distance here was 100. Could you use Pythagorean theorem to find that other distance? Sure. Do you know what problem with that is, though? And I've preached this the whole time. If you're building a bridge and you use a rounded answer to find another answer, what does that do to the second answer? It's not going to be exact. It's going to be a little bit further off. X is not 8.7. Notice the squigglies. X is about 8.7. If you want to truly use Pythagorean theorem, what you really need to do is go back to your calculator and use that value. the answer squared plus 100 squared or whatever, and then do it that way, because actually this is not even exact. That decimal, this is an irrational number. That decimal goes forever. It's not, you're not going to get an exact unless you use that, the answer button on your calculator, because it uses the exact answer. So you can use Pythagorean theorem, but your answer is going to be a little bit off. So let's use trig again. This is an exact answer, or this is exact, and I'm looking for this. If you use your exacts to find it, then your answer is going to be fine. So now again, I ask myself, SOHCAHTOA, if I have a sine, a cosine, or a tangent problem. I have an angle, I have this adjacent side again, and I'm looking for now the hypotenuse. So if I have an angle, I have an adjacent side, and I'm looking for the hypotenuse, which one do I use, sine, cosine, or tangent? Cosine. Because I have an adjacent, and I'm looking for hypotenuse. So we set it up again. The cosine of my angle is equal to adjacent over hypotenuse. Don't just assume that the y is going to be on top, that your variable is always on top, because it's not. These are a little bit tougher to solve. I don't know if you remember how, anytime you have the y on bottom, here's your shortcut. If your y is on bottom, the easiest way to solve these is put the other side under 1, and you now have a proportion. And to solve this proportion, Carly, which two things do I multiply first? 101. We're going to multiply those, and I believe I'm going to get 100 when I multiply them. And then I'm going to divide by what, Carly? Cosine of 5. So my answer is going to be 100 divided by the cosine of 5 degrees. That's how you would type it in. Makes sense? So we take our calculator back out, and we type in 100 divided by the cosine of 5, enter. And I get 100.38. Or about 100.4. So it wasn't much bigger than 100, was it? Because that incline, it wasn't a very steep incline. So the distance from here to here was 100. The distance from here to here was 100.4. Now let's work it the other way and just see how close would we have gotten. The distance from here to here is 8.7, roundabout. The distance from there to there was 100. So let's do a squared plus b squared is c squared. 100 squared plus 8.7 squared equals c squared. Or to type the whole thing in, let's just do the square root of this whole side. Square root of 100 squared plus 8.7 squared gives you 100 point. Do you see it's just a little bit off? It was pretty close. You would have still got 100.4. It would have just rounded a little bit different. But it's pretty much the exact same answer. So if you want to use Pythagorean theorem, instead of 8.7, what I would have probably done was use 2 or 3 decimal places. Because let's see, if I would have used a few more decimals, let's see how that would have changed my answer. Let's see, it's instead of 8.7 right there, it's actually it's actually 8.7. Let's do 4887. See how close that answer is now. The more decimal points, the more accurate your answer is going to be. So instead of using 8.7, if you'd have used a more accurate version, your answer would have been a little bit closer. Okay, we did that one yesterday, Let's do another word problem here. The front of vacation cottage shown is an isosceles triangle. What is the height of x of the cottage above its foundation? So I'm just going to copy this part, the right side of that cottage, because that's your right triangle. You're looking for how tall it is. You're given that this is a 60-degree angle. This is y. I think they're probably going to ask for it in just a second. What is the length of y of the roof length? Now the whole bottom is 65. Now we got to revisit something here. In an isosceles triangle, do you remember what an altitude does? Or in this case, it's an altitude, it's an angle bisector, it's a perpendicular bisector. What's going to be true about the bottom? It halves it. This line is going to cut it into 2 perfectly even spots, so this is going to be 32.5, half of it. And we want to know, first off, and I'll do it in red, what is the height of my cottage? Here's my angle. I'm given Okay, what's that side? The opposite, adjacent, or hypotenuse?
30, 69.
It sure is. Yeah, we're going to do it that way in just a second. That's exactly right. It's going to be a whole lot easier like that. Good. So this 32.5 would be your adjacent, like you said, and we're looking for the opposite. Isn't X your opposite here? So that would be opposite and adjacent, I believe. That would be a tangent, TOA. The tangent of 60 degrees is equal to opposite over adjacent. To solve that. Now, do I have to do it as a proportion? No, you can if you want to. You could put that over 1 and solve. But to get rid of divided by 32.5, you're coming to the other side and you're going to multiply by 32.5. So you've got 32.5 times the tan of 60. Anybody got a scientific calculator there? I can type it in here. Type it in with me, though, just to check yourself. 32.5 times tan 60, and I get 56.3. So X is about 56.3 feet tall. If the bottom is 32.5, or the whole bottom is 65, then it's going to be about 56.3 feet tall. We should know, honestly, what Y is before I even work it. Now, the relationship he mentioned, is this not a 30, 60, 90? Would that not be the easiest way to work it? Hands down, yes. Reminder in a 30, 60, 90 triangle. If you're given, in this case, we're actually given the shorter side. The relationship between the shorter side and the medium side. What do you multiply by? So let's try it like that. Let's see, do I get the exact same answer? That's 32.5. 32.5 times the square root of 3. Exact same answer. 56.29. 56.3. Okay, that'd been a whole lot easier. What is the relationship between the shorter side and the hypotenuse?
Double.
It's double it. So this should be 65. Okay, and my head's starting to hurt now. There's so many connections happening here, but hang on. So if this is 65, what was the length of the bottom? 65. Is this a true isosceles triangle? Or is it a equilateral? Why could we have told from the very beginning that this is an equilateral triangle?
The 60 degrees.
See that? If you've got a 60 degree here, since it's isosceles, this has to be 60. And if you got 60 and 60, the third angle would also have to be 60. This is equilateral. So if this bottom, whole bottom was 65, that means that has to be 65. So many connections there. Now let's work it with trig, though, just to give you some extra practice. If we're given that this is 32.5, don't use this. That's rounded. Try to stay away from it when you're finding your other answer. This is a 60 degree, and now I'm going to try to find y. I'm given adjacent. I'm looking for hypotenuse. That would be a cosine problem, right? The cosine of 60 degrees is equal to adjacent over hypotenuse. Now that one you got y on bottom, so solve it like a proportion. We're going to multiply 1 times 32.5, and somebody's got a calculator. Just type this in for me. We're going to do 1 times 32.5, which I believe is 32.5, and then we're going to divide by cosine of 60. Somebody type in for me, please. 32.5 divided by the cosine of 60. And you get, should get, 65. That's what we've already said it was. Okay. So you can solve it either way. You can solve it with a 30, 60, 90 triangle, or you can solve it with basic trig there. Any questions? Okay, now let's do it backwards. Let's work it backwards. Inverse trig ratios. And let me give you in a nutshell what all this is saying. Sine of x is, let's do 0.5. If the sine of x is 0.5. Now let's go back and let's look at the equations we've been solving. It's been like sine of 30 equals x over 5. Do you notice where the x's were before? They were on the other side. We had the angle. We were given the angle. But now the problems are going to look more like this, where we're not given the angle, we're looking for an angle. And how do we find that angle? Okay, let's go back to some basic math. X plus 3 equals 7. How do you get the 3 from the left side to the right side? Subtract. the inverse operation, the opposite operation. X minus 3 is 10. How do you get the minus 3 from left to right? Add 3. Let's go through all of them. 3x is 9. Colton, how do I get the 3 from the left to right? Good. X divided by 3 is 10. Riley, how do I get the 3 from the left to right? Multiply. Square root of x equals 4. Jagger, how do I get the square root from the left side to the right side? Not multiply by 2, but square. Raise it to the second power. To get rid of a square root, you square. What about x to the second power? Be really careful with this one. X to the second power equals 16. In that one, Briley, how do I get x by itself? How do I get the 2 from here over here? Square root. And not only square root, do you remember the trick for that one? You got to do plus and minus square root. Those are all inverse operations. So what in the world is the inverse operation for sine? It's called inverse sine. How do I move a sine from one side to the other side? I do the inverse sine. So in these type problems, if I need to move a sine over, if I'm trying to get x by itself and I'm moving sine over here, I'll come over to the other side and I'll turn it into the inverse sine. That's all you got to do. So x would be the inverse sine of 0.5. If I needed to, let's scroll down. Let's do some more of those. If I had the cosine of some angle equals 0.3, how do I get cosine from here to over here? Anybody want to take a stab at that one? To move a sine, I did inverse sine. To move a cosine, you do inverse cosine. So if you're looking for an angle, if you're trying to get the x by itself and you need to move the cosine, x would be the inverse cosine of whatever's on the other side. Tangent's the same way. If you have the tangent of x equals 3/4. To move tangent from one side to the other side, you would do the inverse tangent. Just a side note, and some books will do this. Instead of calling them, and which, I didn't even address this. Guys, a little negative one there. That's the inverse of. Okay, we'll talk more about that when we do functions later on in Algebra 2. Anytime it's a little negative one, that's inverse. It's not raising it to the negative. That's not what it's saying. But the tangent to the negative one, that's the inverse tangent. In some books, they will call this, instead of inverse cosine, they will call it arc cosine. Instead of inverse tangent, they'll call it arc tangent. It's the exact same thing. Okay, it's just another way of saying it. And arc sine would be the other one. So, with that said, use a calculator to find the angle. We've not done this. We've got two side lengths in this right triangle, and we need to find the angle. Find angle A. You start out by saying sine, cosine, or tangent. What type of problem do I have? Saw, ca, toa. Hopefully we'll be able to spell that by test day. You're looking for angle A. You're given the, 18. Is it opposite, adjacent, or hypotenuse? Opposite. You're given the opposite, and the 27 is your, so what type of problem is this? The sine of your angle, what do I put in the place of the angle? X. You don't know what the angle is. You can put A if you want to. It doesn't matter what letter you use. The sine of my angle, which is what I'm looking for, is equal to opposite over hypotenuse. These are actually easier than the other ones. Briley, I've got to figure out what X is. So how can I move the sine over there?
Opposite side.
Opposite sine. Okay, opposite's fine. I'm good with that. The opposite or the inverse sine. So X would equal the opposite or inverse sine of 18 over 27. You type it straight into your calculator and you're done. So pull up my calculator. Now, where in the world do we find opposite or inverse sine? It's always right above sine. Inverse cosine, inverse tangent. See, it's in the yellow. Here's how you use it. If you want one of the yellow functions, you hit the second key. So second sine, notice the inverse sine of 18. I don't have a fraction button. Where's that at? Somebody know? See a fraction button there? What's a fraction bar? What's that mean? Look, on this calculator, it even writes it as a fraction bar. The inverse sine of 18 over 27, close your parentheses, enter, 41.8 degrees. Most of the time it'll say rounded to the nearest degree, so x is about 42 degrees. I handle that? So if you've got 18 and 27, you know that this is a 42 degree angle. You actually also know that this is a 48 degree angle from previous lessons. The three angles have to add up to 180. In a right triangle, the two acutes have to add up to 90. So 42 and 48. And you could also even find this other missing side. 18, 27, Pythagorean theorem, right? I'm not going to do it, but you could use a squared plus b squared equals c squared to find that third side as well. And that's called solving the triangle. Anytime they say solve this triangle, they're going to give you two pieces of information. You have to tell them everything else. Okay? That'll probably be what your test is like. Well, here you go. Solve the right triangle. Round side measures to the nearest tenth. Let's go ahead. The easiest one is, well, did they tell me to solve the last one? No, they just said find an A on that one. The easiest one here to find is hypotenuse. A squared plus b squared equals c squared. So how I would type that in is just going to be easier. To get rid of a square, square root the whole thing. And type it in as a square root of 25 plus 81. I'll do that. The square root, let me clear that. Square root of 25 plus 81 gives me 10.29, or 10.3, we'll call it 10. Round each side lengths to the nearest tenth, so yeah, 10.3. Now we got to find angle x and angle y. Let's find angle x. I'll do it in red. Let's look for angle x first. We've got to determine, is it a sine problem? Is it a cosine problem? Or is it a tangent problem? Help me out with it, Trace. Here's my angle. Then, well, first off, since somebody tell me, are we going to use the 10.3? No, it's rounded. Try to stay away from it. We've got two whole numbers here. Let's use those. Trace the 9. Is that opposite, adjacent, or hypotenuse? Good. And the 5 is your? This is your, good, because that's your hypotenuse, right? You say your right angle, that's hypotenuse. So that'd be a tangent problem. Opposite and adjacent. The tangent of my angle is equal to opposite over adjacent. The tangent of x is 9/5. Hunter, how do I get my tangent from here to over here?
Inverse.
Yeah, so you just have to do the inverse tangent of that, and you're done. So we take our calculator out. We do the second tangent of, was it 9/5? Of 9/5, enter. 61 degrees. So x, let me clean it. Whoops, shouldn't have erased that. X is 61 degrees. That was 10.3. Now, do we need to do this again to find y? No. The three angles of a triangle add up to 180. So if that's 61, this will be 29 degrees. And that's 90, 10.3, 5, 9. You solved it. You know all the sides. Okay, that's how you solve right triangles. We're going to do angle of elevation, angle of depression, and then we're finished. We're not going to do law of sines and cosines today. We'll do that Monday. Angle of elevation and angle of depression. What an angle of elevation is. Let's say here you are standing. Okay, your line of sight, a horizontal line of sight. Okay, you know what that means? If you were looking straight ahead, that would be your horizontal line of sight. An angle of elevation is from that horizontal line of sight, what angle are you looking up at? Okay, this is an angle of elevation. Let's say that you're looking at this person up here on the top. Okay, so that's your angle of elevation is, okay, if you're looking straight ahead, that's your horizontal line of sight. If you look up at him, whatever angle your sight changes, that's your angle of elevation. Now, he also has an angle. What if he's looking straight ahead? There is his horizontal line of sight. What if he's looking at you? Whatever angle that his sight goes down from the horizontal down to whatever it takes to look at you, that would be an angle of depression. Elevation going up, depression going down. Angles of elevation, angle of depression. Now somebody explain to me what's true about that angle of elevation and that angle of depression right there, and why. What's going to be true about those two angles? First off, what's true about this line and this line? They're parallel. They're horizontal line. They're looking straight ahead. Those are parallel lines. So these two angles are what kind? Yeah. Angle of elevation, angle of depression are alternate interior angles. So they are congruent. An angle of elevation and the angle of depression will always be the same. If I'm looking up at him from a certain angle, he's going to be looking down at me at the exact same angle. Okay. So Leah is meeting friends at the castle in the center of an amusement park. I suppose it's Disneyland. Let me blow it up so you can see. She's meeting her friends at the castle. She sights the top of the castle at an angle of elevation of 38 degrees. Here she is. Okay. There's her horizontal line of sight. But she's looking up at an angle of elevation of 38 degrees. From the park's brochure, she knows the castle is 190 feet tall. If Leah, now why is that important? Leah's about 5.5 feet tall. How far is she from the castle? And you see what you can do with that. If you're carrying your calculator around with Disney World with you, and you know how high things are, or how tall certain things, you know exactly how far you are from it. If you can sight angles of elevation, angles of depression, and I'll show you in a second how you can find angles of elevation. So here's what you've got to be careful of. This side of the castle is 190 feet tall. This side of the castle is not 190 feet though. You see why? She's looking straight ahead. You've got this little extra right here that's the same thing as pretty much her height. It's not going to be that far off. If she's 5.5 feet tall, then you might be 5.4 feet up to your eyes. Okay, it's not going to be that much further off. But what's this side? I saw you typing it in, Alex. What's this side of the triangle going to be? 184.5 feet. She is looking up at the top of the castle from an angle of 38 degrees. She wants to know how far she is from it. So pretty much she wants to know what this is, the distance. We first decide, is it going to be a sine, cosine, or tangent problem? We're given the opposite side. We're asked to find the adjacent side. What type of problem is that? Good. The tangent of my angle is equal to opposite over hypotenuse. The x is on bottom, so I would put a 1 on bottom as well and solve it like a proportion. Tell me, Hunter, even if you don't have a calculator there, tell me, how would you type that into your calculator? How would you solve that? How would you solve that proportion? What two things do you multiply together?
1.
Good. And you're going to get 184.5, right? And then what do you do with that leftover number? Put it on bottom. Divided by the tan of 38. So in your calculator, you would type that in as 184.5 divided by the tangent of 38. And Alex, once you get that, tell me what you get. 236 point what? We'll call it 236.1 feet. Since this has got 1 decimal, we'll put that with 1 decimal as well. 236.1 feet. Well, actually, they say to the nearest feet, so we're 236 feet. It's about how far she is from that. Any questions? I think we got one more problem. Let's see. Yeah. Let's just do this one right here. That will be good. The crossbar of a goal post is 10 feet high. If a field goal attempt is made from 25 yards from the base of the field goal post that clears the goal by 1 foot. That's a fun problem. What is the smallest angle of elevation at which the football could have been kicked to the nearest degree? So you've got goal post. You got the football right here being kicked. It says that it clears the goal post. The goal post is 10 feet high, but it clears it by 1 foot. Or 1 foot. So here it is. How tall is the football as it goes through? 11 feet. It says it's made from 25 yards. Now, is there something we got to be careful of here? It was 11 feet high when it went through the goal post, and you kicked it from 25 yards out. And that's not from the 25-yard line for all you football lovers. That's from 25 yards away from the goalpost. So do I put 25 yards here? Or do I put 75? Why did I put 75? That's in feet. That needs to be in feet. 3 yards in every foot. 3 feet, no, excuse me, 3 feet in every yard. So therefore, 25 yards would be 75 feet out. We want to know pretty much the angle of elevation. Again, folks, your angle of elevation, here's the horizontal. This is an angle of elevation. That's your x. And a lot of these are tangent problems. I don't know if you've noticed that. That's a right angle. This would be the opposite side. This would be the adjacent side. So the tangent of my angle is equal to opposite over adjacent. Carly, how do I get tangent over there? Because I need to get x by itself. How would you type that into your calculator? How do I move tangent? Remember what it was called? Inverse tangent, good. So I'm going to do the second tangent, or the inverse tangent of 11 over 75. That's not it. And you get 8.3. So to the nearest degree, that's about an 8-degree angle. You have to kick it, in order to clear there, if you're kicking it straight, you'd have to kick it at an 8-degree angle. That makes sense? Okay. I lied to you, there was one more. Let's work it, just to be safe. To estimate the height of a tree that she wants removed, Miss Long sights the treetop at 70-degree angle of elevation. This is a pretty neat problem. Here's what she's doing. When she stands here, the angle of elevation, when she's looking up, her angle of elevation is 70 degrees. Then she steps back 10 meters and sights at a 26-degree angle. So when she's looking at the top of the tree, if she stands here, it's 70 degrees. If she steps back 10 meters and looks at it now, it's at 26 degrees. If Miss Long's line of sight is 1.7 meters, and there it did her line of sight, it did up to her eye. If she's 1.7 meters from the ground to her eyes, how tall is the tree? Okay, let's set this up two different equations. And you've just told me one. Using this angle, this 26-degree angle, the tangent of that angle is going to equal opposite over adjacent. X is your opposite. 10 and y together is your adjacent, so 10 plus y. We also have a second equation. Look at your little triangle. Tangent's opposite over adjacent. So we've got the tangent of 70 degrees. Finish that one for me, Colton. Tangent of 70, opposite over adjacent. What's opposite of 70? What's adjacent to 70? Yeah, what's opposite of 70? X. And what's adjacent? This would be adjacent, right? Y. So you have two equations. And we want to know how tall this tree is. So watch how I do this. It's pretty neat. We haven't done anything with systems of equations this year. So this will be, maybe you remember it from algebra, but just watch how I solve it. I'm going to take the bottoms. First off, let's get rid of all of our bottoms. Let's take this bottom and move it over here. Let's take this bottom and move it over here as well. And my first equation transforms into 10 plus y times the tangent of 26 equals x. My second equation turns into y times the tangent of 70 equals x. So let me ask you something. From this equation to this equation, has the height of that tree changed any? X is x. X was the height of the tree. The height of the tree has not changed any. So doesn't this height equal to this height? What property am I about to use? This is equal to x. This is also equal to x. So what's going to be true about this and this? They're equal to each other. What property is that? Transitive. Good. So I have 10 plus y times tangent of 26 equals y times tangent of 70. This is a decimal, and this is a decimal, and because you've not been exposed to as much algebra as some of the other ones, I'm going to turn those into decimals just to make this a little bit easier to work with. Tangent of 26. Give me that decimal, somebody to the nearest one decimal. Tangent of 26 is 0.5. And the tangent of 70, what's it? Yeah, nearest one decimal. Everybody good with that? Now we just solve it. Now you got to be careful. That's not going to tell us what our y is. That's going to tell us what, or it won't tell us what our height is. It's going to tell us our y. So we got 10 times 0.5. That'll be 5 plus 0.5y equals 2.7y. Move all my y's to one side. I get 5 is 2.2y. Divide by 2.2. Please type that in. So y is about 2.3. Huh. That's fine. 5 divided by 2.2. No. Okay, 2.3. Y is about 2.3. But again, y, I don't know if you remember, y was our distance from the first part to the tree. X was the height of the tree. So to actually find our x is equal to y times tangent of 70. So type in 2.3 times the tangent of 70, and that gives us that x is about 6.3 meters. I think it was in meters. So x is about 6.3 meters tall. That's the height of the tree. Those are tough. That's a really tough problem.